Hello everyone. This video is a part of the series of the videos of the ongoing challenge on LeetCode, which is June LeetCoding Challenge 2020. You can find the link to the complete playlist in the description of the video, where I have added solution along with the explanation for all the challenge problems published till now. With that, let's get moving. This is week 2, problem 3, search in the insert position. So in this problem, you are given a list, which is a sorted list, and you are given a number target. And you have to find the position that if this number target is inserted in this list, at which position will this number get inserted. So for example, in this particular case, if I have to insert 5 in this list, so I can insert this 5 at the second index, which is 0, 1, 2. Okay. So if you are able to find the same number in the list, you have to return the index of that number. And if you are not able to find the same number in the list, for example, in this case, if I have to insert 2, the position where I will be inserting 2 is denoted by the number which is immediately greater than 2. So for example, 3 is the number which is immediately greater than 2. So that is why if I have to insert 2, it will get inserted at the position of the 3, which is index number 1. Okay. So by definition, this is what the lower bound is. So a lower bound of a number is first such number in the sorted list which is greater than or equal to the given number. Okay, and that's the first such number. And since they have told that there are no duplicates in the array also, so we'll not be having any confusion whether what to do with the numbers if they are repeated. So for example, let's just try to run some examples, and let's see like what the lower bound is and where do we obtain the lower bound. So for example, if I have this array, let's not have duplicates. Okay. So suppose if that is the array, and let's just see where the lower bound is, and these are the indices. Okay. So let's just try to find the lower bound for say 1. So which position in this array is the one which is corresponding to a number which is greater than or equal to 1, the first position in this array. So the value is this. So 1 is the value which is greater than or equal to 1, and it's located at index number 0. So the lower bound of 1 is 0. Like the position of the lower bound of 1 is 0. Okay. Next, what is the lower bound of say 4? So in this array, as you can see, 4 is the first such number which is greater than or equal to 4, and it's located at index number 3. So the index of the lower bound of 4 is 3, this one. Okay. Next, what is the lower bound of say 5? So the first such number in the array which is greater than or equal to 5 is this 8, and the index of this 8 is 4. So lower bound, so index of the lower bound of the 5 is 4. Okay. And last, let's say what is the lower bound of say 7. So the first such number in the array which is greater than or equal to 7 is 8, and which is located at index number 4 again. So the lower bound, the index of the lower bound of the number 7 is 4. Okay. And these lower bounds that we have obtained is nothing but the answer to the question that they are asking. So if you have to insert 1 in this list, where will you insert? Of course, you will be inserting it at the 0th location, right? Because if you are able to find the number, then you should directly return that particular index. If you are not able to find the number, for example, in this case or in this case, then you need to return the index, which is index of the number which is immediately greater than this number. Okay. So where do you have to insert 4? If you have to insert in this list, the 4 will go here. Where do you have to insert 5? The 5 will go here. If you have to insert 7, where will you insert 7? The 7 will also go here. So that's what the case is. Okay. So there are two approaches in which we will be seeing how can you implement the solution to this question. First, I'll be doing the approach 2, which is directly using the lower bound function in CPP. Then we'll be seeing the implementation of binary search. And binary search, the topic is relatively very simple as compared to other topics in competitive coding, but the implementation is not always simple. Like many a times people are stuck in the conditions of what to put in the while loop of the binary search, or how to update the mid value, or how to update the low and the up index. And sometimes it's not very intuitive to directly come up with a very accurate binary search implementation. So I'll be discussing a method with you which will clear all the doubts that you have in binary search, and that's one method that will always work in almost all the kind of binary search problems that you will ever encounter. And if you are ever hesitating in implementing the binary search, then after this video you will never hesitate in any kind of binary search implementations. Okay, so first we'll be seeing the approach which is using the lower bound function in CPP. Luckily we directly have this lower bound function in CPP, which directly gives us the solution for this answer, which is the first index of this target, where will it go in the sorted list. So the implementation is also very easy. So you just do index equals, so you just directly call this lower bound function. The arguments are nums.begin, nums.end, along with this target. So this lower bound function always returns an iterator, so you need to subtract this nums.begin from that iterator in order to obtain the index, and the moment you have the index, you just return the index. That's it. So if you see, this is just a one-liner implementation that you have here, because luckily you have this lower bound function in C++. Let's just try to submit this thing and first run this thing. Let's see if it works or not. Yep, let's just try to submit this thing as well. So this gets accepted. Cool. But this is not what the primary purpose of this video is. So what I'll be doing is, I'll be making a separate video on binary search, where I'll be discussing the strategy of the binary search, which will always work across almost all the problems that you will ever encounter. And so hopefully after that tutorial, you'll not be having any resistance, or you'll not be having any confusions regarding how to approach for a binary search problem, and you'll be very confident in implementing binary search as well. So even if you are comfortable with binary search, or even if you are able to implement binary search logics, I would still recommend you to watch that video, because the way I'll be approaching the implementation of the binary search in that video is a very different way, and it's not the usual way how the binary search is taught. So do watch that video. I'll put the link to the video in the comment section, and as always, if you have any comment, any suggestions, do let me know in the comment section as well. So thanks for watching.